here we are to use the polar coordinates. We are to use the polar coordinates to evaluate the double integral of this function. What we need to do here is that we look at the range. The x corresponds to this range. So you can see that with the x-axis, it starts from 0 to 2, somewhere 2. Then with the y-intervals, it starts from also 0 and goes up to some limit. So you can see that we are only interested in this sector, which is the first quadrant, starting from 0 to 90 degrees, and that is the angular displacement. So it means that our polar integration, the first part for the x is going to take 0 to 90 degrees, which is the same as pi on 2 radians. Then the second part is the y value. So we have y to be equal to the square root of 2x minus s squared. So we can have y squared to be equal to 2x minus s squared. And by grouping of like terms, we will have s squared plus y squared to be equal to 2x. But remember that in polar coordinates, s squared plus y squared is giving us r squared. So r squared is equal to 2x. And again, in polar coordinates, s is equal to r cos theta. So by substituting it here, we have r squared. R squared is equal to 2 times the x, which is r cos theta. So from here, we can do some factorization. R squared minus 2r cos theta should be equal to 0. Then we can factorize r out. We have r minus 2 cos theta should be equal to 0. So already we can see that r is 0, or r minus 2 cos theta is also equal to 0. And that means that r is equal to 2 cos theta. So we can conclude that 0 is less than or equal to r, less than or equal to 2 cos theta. And that is going to be the range. So we can also write that as the integral from 0 to 2 cos theta of the given function. Remember that s squared plus y squared is r squared. So we will have root of r squared, root of r squared. Then dy dx is giving us dy dx from polar coordinate is giving us r dr d theta. So we substitute that there, r dr d theta. So by simplifying, we are going to get the integral from 0 to pi on 2. Then also the integral from 0 to 2 cos theta of r squared dr d theta. And this is what we are supposed